Come to order. Without objection, the chair is authorized to declare recesses of the subcommittee at any time. Welcome to today's hearing entitled Oil and Gas Technology Innovation. I recognize myself for 5 minutes for an opening statement. Today, we will have the opportunity to hear about exciting new research and developments in oil and gas. Fossil fuels continue to be America's dominant energy source and provide over 80% of the energy around the world. It's no surprise that we have a robust industry here at home investing in developing the next generation of technologies to help produce American fossil fuels more efficiently, more safely, and at a lower cost for American consumers. Our hearing today will highlight individuals and private sector organizations taking a leading role in oil and gas technology innovation. Much like our committee roster, we see a lot of our Texas innovators on our panel today. As we worked to put together today's hearing, I quickly learned we could fill this room with innovators from across Texas and the country who are exploring new ways to improve a broad range of technologies that can help revolutionize this industry. My staff and I have had the opportunity to talk to researchers from the University of Texas, Texas A&M, University of Houston, Rice University, and the DOE National Labs, all of whom are conducting research that is driven by industry needs. We heard about research in materials science to develop materials resistant to the high temperature and pressure environments that occur particularly in offshore drilling. We even learned about unique applications of nanotechnology to monitor the subsurface and basic research in geology and computing that allows industry to make better decisions about when and where they drill. I want to thank Dr. Ramanan Krishnamoorti. Am I saying that right? Close enough, huh? Okay, you're very kind. From the University of Houston for testifying today and representing the incredible research going on in my home state. I'm a graduate of U of H myself, doctor, by the way, so thank you for being here. I look forward to hearing the Cougars, I look forward to hearing your insight on the nexus between this basic and fundamental research and how it applies in the oil and gas industry. This will bring us to the appropriate role for the Department of Energy. The department has contributed valuable research in this field for decades. Congress first funded DOE's unconventional oil and gas research programs beginning in 1976. And collaboration with the industry has indeed been a core part of DOE's research efforts. Historically, the department has conducted basic and early-stage research, collecting long-term data, and maintaining expertise to provide industry with the tools necessary to achieve technology breakthroughs. Industry then led the next step, building on DOE research to commercialize oil and gas technology. Using this collaborative approach, DOE research conducted by the national labs contributed to the development of key technology for hydraulic fracturing and revolutionized the American economy in the process. Today, DOE continues to make targeted investments in early-stage unconventional oil and gas research, while efforts to deploy new technology are consistently led by the private sector. The department also contributes funding to larger industry-led projects measuring seismic data and analyzing geological formations, like the Gas Technology Institute's research to maximize the efficiency of hydraulic fracturing in the Permian Basin, which we're going to hear more about in testimony today. As we approach the budget season, it is our job as an authorizing committee to make sure that we have a clear picture of what federal research investments provide the most bang for our buck. We know that industry has the skills and resources to fund technology commercialization. but they often don't have the tools to conduct early-stage research and maintain that historical data like the DOE National Labs can. With that in mind, DOE should prioritize the basic and early-stage research that provides data and analytical tools to researchers and allows the private sector to commercialize groundbreaking technology. I want to thank our witnesses for testifying today, and I look forward to hearing more about your innovative research. And with that, I will recognize my good friend from Texas, Mr. Vesey.
Thank you, Mr. Chairman. Would like to thank you for holding this hearing, and thank you for having the witnesses here today. It looks like we have a really good, distinguished panel. Glad that there are two Texans leading this discussion on energy and oil production technology, and it really is amazing how that technology has played such a major part in the world changing just in the last 2 years. It really is very, very miraculous, and as you know, the state of Texas represents the largest share of U.S. Oil and gas industry. And everyone here knows that we produce more crude oil, and we also produce a lot of natural gas. And this industry has been a major economic driver for our state for a long time, employing hundreds and thousands of Texans. In order to continue this economic success, it is necessary for our state to lead the way in making oil and gas cleaner and safer for the environment and public health. I'm happy to see that everyone on the panel today can speak to the crucial importance of the environmental mitigation in the extraction, production, and consumption of oil and gas. I look forward to hearing everyone's insights and ideas because even though there has been some disagreement, we all know for certain that human activity has contributed to the warming of the climate. And the scientific community has made clear that we all need to take some sort of action on climate change. And so what does this mean for the oil and gas industry? The shale gas boom can take credit for much of the U.S. emissions reductions over the last 5 years. Much of the power generation sector has switched to natural gas, and we've enjoyed the benefits of this cleaner burning resource. However, this is not a sufficient long-term solution to lowering our emissions. Methane, the largest component of natural gas, has 84 times the heat-trapping capacity of carbon dioxide over a 20-year span. Aging infrastructure, greater storage demand, and a growing pipeline network present a number of challenges in monitoring and preventing these leaks. The most notable leak since the shale gas boom occurred in 2015 at the Aliso Canyon Storage Facility in California. The leak resulted in the release of 109,000 metric tons of methane into the atmosphere. While methane is colorless and odorless, we know the impact it can have on the environment and the health of our own communities is evidenced by this incident that we saw in California. Methane leaks are unique in that the environmental incentives align with the profit incentives of the industry. But it also can mean a loss of profit for industry. But working together, we can provide the incentives and research necessary to drastically reduce methane leaks by closely aligning the industry's bottom line with our urgent need to protect the environment. The increased reliance on natural gas also highlights another long-term challenge, and that is the deployment of carbon capture technologies. Use of this resource still pumps out greenhouse gases at an unsustainable rate, and that is why we must accelerate the deployment of carbon capture technologies, not only for coal-fired plants, but also for natural gas power generation. According to the International Energy Agency, carbon capture and storage technologies are vital to enabling a robust global response in addressing the threat of climate change. The necessity is reflected in the Paris climate negotiations, and we are not short on innovative concepts. I particularly look forward to hearing from Mr. Dimmig on Net Power's unique zero emissions design that they are trying to commercialize in Texas in the next few years. Before I finish, I would also like to note that during today's dialogue, we may hear a few inaccurate or misleading statements comparing incentives for fossil fuel versus those for various forms of renewable energy and energy efficiency. The most obvious inaccuracy in this criticism is the presumption that all renewable energy is the same. It's not, as if solar, wind, geothermal, and hydropower are not all unique forms of energy generation. Claiming a lack of parity in research and development funding by comparing fossil energy research budget lines to budgets for efficiency and all of these renewable sources lumped together is not only misleading, it ignores the basic fact of how our energy markets work. Fossil energy has enjoyed strong government support for the past century, including tax incentives, subsidies, research, development funding. In fact, the current boom in natural gas production can be traced back to research on horizontal drilling and hydraulic fracturing pioneered by the Department of Energy in the 1970s. Moreover, fossil energy commands strong control over the electric generation and transportation markets. And yet some of my Republican colleagues cry foul when the biggest energy companies in the world do not receive the same dollar-for-dollar government support as all other energy industries combined. I strongly support government research and development to advance energy efficiency, the wide range of renewable energy technologies, and nuclear power. However, this does not mean that the Department of Energy can't or shouldn't support a robust portfolio of fossil energy research and development as well. This area of research requires a strong partnership between government and industry focused on mitigating the environmental impacts of fossil energy generation. The Department of Energy's work in this space is vital to our environmental priorities. I hope we have the opportunity this Congress to collaborate with our colleagues in the majority in examining how we can prioritize and expand the Department's R&D in this critical area. Mr. Chairman, thank you for your patience. I know I went over my time there, and I yield back the balance of my time, and again, I want to thank the panel for being here.
Thank you, Mr. Vesey. I now recognize the chairman of the full committee, Mr. Smith.
Thank you, Mr. Chairman. And I want to say this is an important subject today and appreciate you having a hearing on it. Today we will discuss recent breakthroughs in oil and gas technology. Innovators continue to build on decades of groundbreaking successes in oil and gas production, maintaining America's technology leadership. This area of research is particularly successful due to continued collaboration between industry, universities, and national labs. We also will discuss the appropriate balance between the private sector leadership and the Department of Energy and Applied Research and Technology Development. The oil and gas industry has a long and successful history of maximizing the research conducted by DOE to further technological breakthroughs. Before hydraulic fracturing and horizontal drilling revolutionized oil and gas production, basic and early stage research funded by the department provided valuable tools and knowledge to industry. In the 1980s, Sandia National Lab collaborated with industry to develop the primary drill bit used in horizontal drilling. And Sandia National Lab's basic research in geology led to the development of microseismic fracture mapping techniques for hydraulic fracturing. Industry partners adapted these techniques for commercial use and deployed technology to maximize energy production across the country. The partnership between DOE and the private sector must have the right structure for success. DOE is best suited to provide the early stage research that allows industry the opportunity to commercialize and use new technology in the field. This approach allows for the most cost-effective and efficient technology to be deployed by oil and gas companies. We don't need mandates to motivate producers to use the most efficient production technology. Technology that improves development often reduces the footprint and environmental impact of energy development. It also lowers costs for consumers. R&D is a great way to improve our environment and power our economy. Federally funded research in one area also can provide economic benefits in new technology where we least expect it. One of our witnesses today, David Brower, the founder of Astro Technology, spent his career as an engineer working with NASA and the Department of Defense. After years of working on rocket propulsion and safety, he discovered that he could effectively apply many of the sensor technologies used in the aerospace industry to improve safety in oil and gas development. This is the kind of groundbreaking technology that we cannot predict when we fund basic and early stage research. Like many of my colleagues, I share a commitment to the long-term use of our nation's most abundant and affordable fuel source. DOE's fossil energy research programs can pave the way for industry to develop the next generation of technologies. But for this partnership to be a success, industry must continue to take a leading role. I look forward to a discussion about what policies Congress and DOE should pursue to encourage more industry-led research and development efforts. In Congress, we have the responsibility to ensure the efficient and effective use of American tax dollars. By investing in early-stage research and encouraging strategic partnerships between DOE and industry, we will ensure that our vast natural resources will continue to provide affordable and efficient fuel for the American economy. Mr. Chairman, before I close, I want to recognize James Danford, who is sitting right behind me, and he is our Science Committee legal assistant and speechwriter who has helped me at numerous committee hearings and markups over the past 5 years. James' last day on the committee will be next Friday. He has been attending Georgetown Law School at night while working at the Science Committee full-time and will graduate May 21st. James and his wife, Krista, my executive assistant, will be moving back to Texas for James to take a job at a Houston law firm. James and Krista have each been on my staff for almost 6 years. They are expecting their first child in July. So we wish them health, happiness, and success. And James, will you stand up and let us give you some applause here? Yeah.
So, James, did you meet your wife here on the Science Committee?
No, we've been dating since high school.
Okay. So it took you a long time. I see how you are. So thank you, Mr. Chairman. And I now recognize the ranking member of the full committee for a statement. Ms. Johnston.
Thank you very much. Let me congratulate James and say good wishes for the future. And thank all of our witnesses, Mr. Chairman, for being here. This is an interesting topic. I think it's interesting to note that both the chairman, ranking member of the full committees, and the subcommittee chairman and ranking member, all Texans, and the Secretary of Energy now is also a Texan. So you can tell that there's interest in this topic in Texas. Certainly the oil and gas sector is in one area in which we see how advances in science and engineering can produce large-scale economic value, and our federal R&D agencies have played a historic role in this process. Just over a decade ago, we had little idea of the fossil resources that would be available to us today. However, due to some critical research investments made by the Department of Energy over 40 years ago, coupled with rising oil prices in previous decades, the American economy underwent the shale gas revolution, bringing major natural gas resources online, and with it, a sharp increase in domestic oil production. The DOE, that program in DOE wrapped up in the early 90s when a private company took the research performed by DOE and used it to ignite the oil and gas boom we see today. I think my colleagues would agree that that is the model of DOE's energy technology programs that we all hope to see. Federal investments shepherding transformative technologies to the marketplace, even when the end point is not clear at the beginning of the process. That brings us to what should be fundamental questions today. Where should the Department of Energy be investing limited dollars in this area? If the standard of identifying of a government role rests in whether the private industry has the capacity to invest in R&D, then I think the answer to the question of DOE investments in oil and gas is that the federal role should be very limited. After all, it is hard to think of a sector that is much more commercial and on average more profitable than the oil and gas industry. For this reason, I believe the department should focus its investments on environmental mitigation. At present, there is little incentive for industry to spend major R&D dollars to protect the environment. If this hearing is intended to highlight the importance of oil and gas to the economy, hopefully I can save us some time. I am from Dallas. Oil and gas will play an important role in our nation's economies for decades to come. My hope is that our outcome of these hearings will be to push the present administration to reconsider its position to drastically reduce R&D funding for fossil energy. I would support that endeavor as long as it comes along with strong support of DOE's other energy technology programs. When it comes to R&D funding, Republicans and Democrats should be speaking with one voice. Investments in R&D benefit our nation. In closing, I'd like to challenge the current administration and our colleagues on this committee to be forward-looking in our push to develop the next generation energy economy. Drilling our way to economic growth while ignoring the long-term impacts cannot be the answer as we face a warming climate and the significant consequences that come along with that. Our environment and the health of the public is on the line. And so I thank you, Mr. Chairman, and I yield back the balance of my time.
I thank the ranking member, and I'll introduce the panel. Our first witness today is Mr. Edward Johnston, Senior Vice President for Research and Development at the Gas Technology Institute. Mr. Johnston received his bachelor's degree in mechanical engineering from Mississippi State University and his MBA from University of Chicago's Booth School of Business. Then our next witness today is Mr. David Brower, founder and president of Astro Technology. Mr. Brower received both his bachelor's degree in material science and mechanical engineering and a master's of science degree from the University of Utah. And then our next witness is Mr. Walker Dimmig, principal at 8 Rivers Capital, LLC. Mr. Dimmig received his bachelor's degree in political science from Middlebury College. And our last witness is Dr. Ramanan Krishnamoorti, Interim Vice President and Interim Vice Chancellor for Research and Technology Transfer at the University of Houston and University of Houston System, go Cougs, as well as Chief Energy Officer at the University of Houston. Dr. Krishnamoorti obtained his bachelor's degree in chemical engineering from the Indian Institute of Technology, Madras, and doctoral degree in chemical engineering from Princeton University. I now recognize you, Mr. Johnston, for 5 minutes to present your testimony.
Thank you very much, Chairman Weber, Ranking Member Veazey, Chairman Smith, and Ranking Member Johnson, and the rest of the members of the subcommittee. On behalf of GTI, I'd like to thank you for the opportunity to testify before you today regarding innovation in the upstream oil and gas sector. My name is Eddie Johnston. I'm the Senior Vice President of Research and Technology Development at GTI, and we're an independent, not-for-profit R&D organization. Our vision is to turn raw technology into practical energy solutions that have meaningful impact for both the economy and the environment. I'm here to talk about shale research, and while shale development seems like an overnight occurrence to most, decades of research and cooperative field experiments by GTI and DOE underpin the technical complexities of producing this resource. Shale rock has very low permeability, so stimulation can be very challenging and require significant energy. In shale formations, the recovery rate is typically below 20% for gas and 10% for oil, and sometimes even much lower. This is the grand challenge. Field experiments we've conducted indicate that as many as 80% of fracture treatments do not significantly contribute to overall production. Effective, yes. Efficient, no. This inefficiency has direct environmental implications, and by optimizing fracture efficiencies, fewer wells will need to be drilled, which leads to fewer trucks, less water, reduced emissions, and less community impact. To address these issues, GTI launched the Permian Project, our hydraulic fracturing test site in West Texas. Our goal is simple in concept: substantially advance the hydraulic fracturing process to optimize well spacing so fewer wells are needed. The problem, though, is multifaceted. Subsurface completion science continues to be a complex process with many variables that affect the locations where fractures propagate, their dimensions, and their ability to enhance production. Direct and reliable data is still needed about the size, shape, and distance that hydraulic fractures actually propagate. Optimizing resource recovery techniques requires input from the best and brightest from industry, universities, national labs, research institutes, and the only way to realistically do this is via public-private partnership. So with the assistance of a $7.4 million cooperative agreement from the Fossil Energy Office, GTI was able to pull together a partner in Laredo Petroleum that provided a test site and personnel in the Permian, along with $100 million of microseismic and other background data. A joint industry partnership of Chevron, ConocoPhillips, Core Labs, Devon, Discovery Natural Resources, Encana, Energen, Halliburton, Shell, and Total that sponsored the additional $16 million of research work and also provided subject matter experts to contribute to the scope, and a team of leading researchers from the University of Texas, the Bureau of Economic Geology, and NETL. And over this 11-well experiment, more than 400 fracture stages were monitored, and we continue to study the production from these fractures today. But the key differentiator of this work is the $6 million core well, as we captured 600 feet of unique cored through fracture zones by drilling a one-of-a-kind slant core well. More people have actually examined rocks from the moon than they have through fractured core. Extracting core of this magnitude is an expensive and risky undertaking, but this ground truth evidence is critical to understanding fractures and improving models, and to consider how predictive analytics can improve the process. Important data about propagation and proppant transport dynamics will lead to the design of optimal fracture treatments and ultimately ideal well spacing. Many of the findings will likely be transferable to other basins, but shale is a heterogeneous resource, so much work is still needed to be done. We have planned future work in the Permian and signed a letter of intent with BHP Billiton for a test site in the Delaware Basin, part of the Permian, that is deeper at higher pressures and temperatures and different permeability than the Laredo site. Interested partners are looking for a commitment from DOE that signals continued support for this type of important research. This investment will be the catalyst for the next phase of learning. In conclusion, shale has recalibrated world energy markets, helped resurrect our economy, provided U.S. consumers clean, affordable energy. Much has been accomplished by the mechanical innovations by industry, but the subsurface science work is clearly incomplete. Continued field experiments are critical to achieve desired recovery rates for more responsible development. The involvement of the public funding ensures the results are ultimately shared broadly rather than being held by a select few. This will allow us to maximize our national energy resource and accelerate our path to energy security and independence. Thank you again for this opportunity to speak today, and I'd be happy to answer any questions when the correct time.
Thank you, Mr. Johnson. Mr. Brower, you're recognized for 5 minutes.
Mr. Chairman, members of the committee, thank you for having me here this morning. As mentioned, my name is David Brower. I have much experience in science and technology and have spent my 37-year career working on rocket technology for defense and space applications. I've also worked in the energy industry for over the past 20 years. The combination of aerospace, energy, and government experience has allowed me to develop and implement entirely new high-technology methods into the energy industry. The primary objective of my work has been to identify and prevent potential problems before they occur. In doing so, we should be able to mitigate environmental contamination from hydrocarbon spillage in offshore and land-based operations. For example, to head off catastrophic events such as the major oil spill in the Gulf of Mexico during summer of 2010, and many less publicized smaller spills are candidates also. The innovative methods also improve safety and help increase production and operation capabilities. Since I formed Astro Technology in 1994, I have been a committed advocate of strong working relationships between government and industry. Currently, we work under a Space Act agreement with NASA. The resulting work activity has been instrumental in transfer of high-technology methods into the energy industry. Twice, in 2004 and 2015, our efforts have been highlighted in NASA's annual spin-off report to Congress. This highly effective government-to-industry approach has led to several deepwater sensor implementations in the Gulf of Mexico, with several others in progress. I should mention that our collaboration has included university support as well. Consequently, we've been able to identify and potentially prevent structural failure, ensure environmental protection, and at the same time, improve operations. Our venture began with the START Treaty as part of the counterproliferation of weapons of mass destruction in the republics of the former Soviet Union. As a result of that work, I was successful in development and application of new advanced sensors. In mid to late 1990s, several oil and gas companies approached me about solving problems on a deepwater pipeline in the Gulf of Mexico. They needed a sensor that could measure pressure on the interior of a subsea pipeline that did not require penetrations leading to possible leak paths. After the successful task, several more oil and gas projects resulted. 20 years later, significant progress has been made with NASA's assistance to advance technology in oil and gas. Much more effort is needed. Astro Technology started a research and development project called ClearGulf approximately a decade ago. This effort includes 10 research areas such as identification and mitigation of structural integrity that could cause significant hydrocarbon spillage. Flow assurance monitoring is another research area we're addressing to prevent blockage of flow lines from hydrocarbon or anhydrate formation. Also, advanced robotic development will fill a significant gap in current large-scale, remotely operated vehicles. The new robots would work and live subsea. They will have dexterous capability and perform finesse work operations mimicking human capability. Another exciting research area is the repair of older or soon-to-fail structures that are in deep-water fields. By definition, I believe the role of small business in new advanced methods is clearly that of innovation. Large companies are highly suited for implementation, and government as support, encouragement, technology direction, and possible incentives. It can be very difficult to achieve implementation of new technology methods. A stronger alliance between government and industry could solve that problem. I've been very fortunate to have a string of successful projects. My journey would have been much more difficult without government support. My thoughts going forward involve a stronger working relationship between small business, mainstream oil and gas companies, universities, and U.S. government. My experience with oil and gas companies has been very positive. They sometimes have fear of trying anything new. However, as we move into future endeavors, it becomes increasingly important to develop and apply advanced technologies to ensure environmentally clean operations, trouble-free work effort, and better control of operational processes. In conclusion, I recommend the formation of a short-term task team that addresses the issues discussed. The team should consist of small business entities, DOE, several subject matter experts from large oil and gas companies and universities. Thank you again for the invitation and your attention.
Thank you, Mr. Brower. Mr. Dimmig, you're up.
Thank you, Chairman Weber, Ranking Member Veazey, and members of the committee. I appreciate the opportunity to discuss energy technology innovation with you today. 8 Rivers is a technology commercialization firm focused on developing breakthrough industrial innovations. Today, I'll be sharing perspective gained from developing one such innovation on the natural gas utilization side, known as the alum cycle, which is a new direct-fired supercritical CO2 power cycle for use with natural gas or coal. It projects to compete on a cost of electricity basis with existing best-in-class power plants today. Importantly, the technology does this while producing virtually no air emissions. Water and high-pressure, high-purity CO2 are the only byproducts of the cycle. Because the cycle can inherently produce pipeline-ready CO2, it presents an opportunity to transform the enhanced oil recovery industry by providing a supply of affordable CO2, which would enable over 100 billion barrels of domestic oil to be accessed, even in low oil price environments. In order to produce this oil, billions of tons of power sector CO2 would be sequestered. In short, the alum cycle has the potential to be a major win for the electricity sector, the oil and gas industry, the environment, and consumers. Today, Net Power, a company owned by 8 Rivers, the power company Exelon, and the engineering firm CB&I, is building a 50-megawatt thermal pilot-scale natural gas demonstration plant down in La Porte, Texas. with over $140 million in private investment into it. The plant is within months of entering into operation, and it is designed to provide the information required to then build the first 300 megawatt commercial scale natural gas plant. 8 Rivers' experience in commercializing this technology and others supports the view that federal government support has an important role in energy technology development, from R&D through to deployment. The R&D process is long, expensive, and highly uncertain. Without government participation at this stage, it would be difficult for 8 Rivers to execute on its model for commercializing important energy innovations. Examples of federally funded R&D are present all throughout the alum cycle. Most commonly, 8 Rivers has been able to take proven R&D that was originally pursued for other purposes, such as materials for supercritical coal boilers or heat exchanger learnings from a solar program, and apply that technology in the alum cycle. In addition, the DOE has a new supercritical CO2 cross-cutting initiative, and we're hopeful this program will lead to opportunities to further advance the alum cycle in important ways. But our experience is also that public-private partnerships remain critical all the way through to deployment of first-of-a-kind commercial plants. The alum cycle is currently entering this challenging period. A first-of-a-kind commercial facility needs to operate successfully in the market against fully mature technologies, and yet it has to do so with costs that are significantly higher than even the second facility of its kind. Reasons for this can include inefficient supply chains, designs that have not yet been fully optimized, large first-time engineering costs, increased contingency fees, and even less competitive warranties. Programs that partner with the private sector through grants to assist in building first-of-a-kind projects can be essential. One such program is the Clean Coal Power Initiative. Importantly, a similar program for natural gas projects, such as the one Net Power is now pursuing, does not exist. Cost challenges do not completely dissipate by the second plant. They reduce over time. Ongoing assistance for these projects through mechanisms such as a reformed 45Q tax credit for CCS can be critical to ensuring these technologies are able to reach their full potential and are not just developed into niche applications. Finally, we believe federal R&D programs should be very goal-oriented across the technology portfolio, and rather than being too technology prescriptive, programs should have the flexibility to pivot with industry to achieve those goals. For example, 8 Rivers began by developing the alum cycle for coal, but it became quickly apparent that the coal development pathway must first proceed through natural gas. This was the lowest cost, least risky, and most impactful approach. Similarly, federal programs could benefit from being structured to work with both coal and natural gas utilization technologies, as this flexibility could help technologies move forward for one fuel in a way that also represents a major advancement for the other fuel and achieves broader program goals. Thank you for the opportunity to testify today, and I welcome any questions you have.
Thank you, Mr. Dimmig. Dr. Krishnamoorti, you're up.
Thank you so much, Chairman. Thank you for asking me today to talk about the critical partnership between academia, industry, and national labs that are helping move the oil and gas industry forward. My name is Ramanan Krishnamoorti. I'm the Interim Vice President, Vice Chancellor for Research and Technology Transfer at the University of Houston, where I'm also the Chief Energy Officer. Guided by a distinguished panel of our Energy Advisory Board, comprising top executives from the energy industry, we at UH are committed to becoming the energy university. At the University of Houston, located in the energy capital of the world, we strongly believe that fundamental advances in science and engineering, when appropriately coupled with industry-based pull, can help transform the capital-intensive oil and gas industry. Just as hydraulic fracturing and horizontal drilling have transformed the availability of shale oil and gas, UH is working with industry, the national laboratories, and other academic institutions to create the next transformative technologies to advance conventional and unconventional, as well as terrestrial and offshore oil and gas. We are focused on dramatically increasing the amount of hydrocarbon resources that can be recovered while minimizing the impact on the environment, and therefore ensuring the continued supply of affordable energy solutions. Such a focus requires commitment to all aspects of the oil and gas industry, including regulation, business policy and management, public policy, human factors, and naturally, fundamental and applied science, engineering, and technology. In my written testimony, I've provided a detailed report on the impact of the University of Houston in providing innovative strategies to lower costs and develop safer methods to find and produce oil and gas. These innovative solutions include responses to immediate challenges and strategic long-term disruptive technologies. The key issues are summarized as, I'm going to have 4 points here. First, technology innovations require a strong connection between industry pull for targeted applications and the academic push for fundamental and applied advances in science, engineering, and technology. Some notable examples of industry collaboration-driven advances are the significant speeding up of seismic interpretation through advanced computing, the development of smart cements, developing enhanced oil recovery formulations for high temperature and high salinity reservoirs, and sensing and preventing microbial corrosion of pipelines. For these innovations to continue, the business of oil and gas will require the embrace of human factor-centric design, standardization, and system integration. My second point is disruptive technologies advances in oil and gas are likely to come from fundamental advances in various fields, including nanotechnology, life sciences, data analytics, and cognitive computing. But given the capital expenses and long runways between fundamental research, applied development, deployment, and commercialization, those advances will require continued engagement by federal and state agencies for fundamental breakthroughs and possibly by incubation through engaged national laboratories as technologies are developed. Specifically, engaging NASA Johnson Space Center with the University of Houston and the Subsea Systems Institute for the adoption and deployment of automated underwater vehicles and risk modeling for deepwater missions are examples of best-in-class engagement. My third point, the oil and gas industry is challenged with so-called crew change. As experienced geophysicists, geoscientists, engineers, and others retire, taking with them an enormous amount of expertise over the next 10 years. Academia plays a critical role in partnering with industry in the continued enhancement of the workforce for this industry and the continued engagement of subject matter experts to advance technological solutions. Finally, it is important to emphasize the cyclic nature of the industry with boom and bust cycles all too common. Combined with the long runways for the development of resources such as those in the ultra-deep water and those found in high-temperature, high-pressure reservoirs, the continued development of technology innovations remains critical and requires sustained public investment. Mr. Chairman, at the University of Houston, we are proud of the interactions we have forged with the industry and the demonstrated value of these partnerships. I thank you for the opportunity to provide testimony today and look forward to answering your questions. Thank you.
Thank you, Doctor. I now recognize myself for 5 minutes. This will be a question for all of you, which I'd like to keep short if we can. Your answer, we're going to try to get back to some more questions. In your opinion, what is the appropriate role of government in oil and gas research and development? Let me explain. Are we better off focusing limited federal funds on applied energy research or the demonstration and commercialization of energy technologies? Mr. Johnston?
So I would start by saying the leverage of the funds of the project that we have, I think, are a very appropriate way to utilize that fund. So we're actually taking first principles and marrying them with industry. So trying to get to the fundamental issue that's causing the inefficiencies in hydraulic fracturing, but also bringing partners along with that. I think that is a very appropriate role for these types of funds and these private public partnerships.
Okay, thank you, Mr. Brower.
I think one of the fundamental issues about research in general in the oil and gas industry starts really with the definition of what research and development really is. Because when I made the transition from aerospace into the oil world, research is defined much differently in both those environments. Research in aerospace oftentimes can start with a blank piece of paper and just thoughts as they start to generate. In oil and gas, research typically begins with something that's already somewhat downstream. I think if I were looking at where some of the funding could be utilized very effectively, it would be to have a hybrid of both of those two methods, whereas you're thinking of new innovative methods that could solve some of the problems in oil and gas, and combine that with things that are a little bit more mature.
All right, thank you. I appreciate it. Mr. Dimmig?
I think it's, in our experience, not an either-or scenario. I think we wouldn't have technologies to deploy if we don't have a robust R&D base, and we've benefited from R&D all throughout the Department of Energy, even R&D that wasn't intended for fossil fuels. So we have to start there. At the same time, I think we have to recognize that certain technologies that we think are very promising and the market thinks are very promising are very capital intensive, very difficult to get into the market with that first deployment. And so if we don't follow through with the most promising of those technologies, we might leave them behind.
Okay, got you, Doctor.
I agree with my panelists. It's not an either-or. I think we learn some of our best lessons when we go to deploy them. When we go to deploy technologies, we come back and say, do we have to do a reset of our fundamental basic research that gets applied? And I think we've got to have a complete stream of this. But with the boom and bust cycles that are so common in the industry today, industry funding alone cannot move this industry forward.
Yeah, gotcha. And you're actually my next question. In your testimony, you discussed how oil and gas production is testing the limits of current understanding of engineering principles and presenting new problems along the way. For example, you wrote that, quote, as we access more high-temperature, high-pressure reservoirs with ultra-deepwater exploration and production, the material challenges have become more significant, end quote. You go on to write that your colleague is conducting materials research to develop new polymers to solve this challenge. Engineering is a practical field. Do you think these practical problems are actually leading to basic science research? And before you answer that, you said in your remarks earlier, you wanted U of H to be the energy universe, we want to make sure that happens. Do you think that these practical problems are leading to basic research?
Absolutely. In that basic research in materials design, in materials development, processing, and deployment is where these practical problems are leading to a significant change. And these are not going to just impact the oil and gas industry. It's going to have a much broader application, for instance, in the aerospace industry. We've had challenges in the deep water with the hydrogen-led embrittlement of bolts. This has got parallels to the aerospace industry, and what we've learned from either of those fields has led to really understanding and improving the technology in the field.
Yeah, good, thank you. Mr. Johnston, I'm going to jump back to you. Can you give us an update on the research at GTI's hydraulic fracturing test site? What are some open problems that the scientists and engineers are trying to understand?
What they're really trying to figure out now is actually where the proppant goes through the. So in this project, we actually physically, chemically, and radioactively trace the proppant so that we have a better understanding of what happens within the transport mechanism. So today, it's really more of analyzing the production, inferring information about the physical evidence that we have, and validating and building new models that really help understand, the process. Sometimes you induce as many questions as you answer with projects like this, and I think that's why, continued research in this field is very important.
Well, that's true about a lot of research, isn't it?
It is.
Yeah.
It is.
All right, my time has expired. I'll now recognize Mr. Vesey.
Thank you, Mr. Chairman. And this question is for Mr. Dimmig. Mr. Dimmig, the IEA, among many other widely respected analysts and institutions, has concluded that developing and deploying carbon capture technologies in the power generation sector, notably including such technologies for natural gas-fired power plants, will be critical to achieving the goals of the Paris Agreement. I wanted to ask you, because NET Power is developing a unique design for a natural gas power plant which would completely eliminate the smokestack, how do you see designs like yours fitting into the long-term emissions reduction strategy of the United States and other countries that are participating in the Paris Agreement?
We think it's critical. we've looked at all the sort of major studies out there, and I would agree they all tend to conclude that without CCS, we're not going to get to the various climate goals we've set. So at E-Rivers, we view finding a fossil fuel solution to carbon emissions as a critical requirement, mostly because we also see that fossil fuels aren't going anywhere. We have abundant oil and gas here in the United States. We'll be using that for some time to come. There's abundant oil and gas around the world. Coal is being utilized in the developing world quite abundantly. So we know these fuels are going to be used, and we know in order to meet these goals, we're going to have to deal with carbon emissions from that. Our main goal is to try to make that a sort of an economically irrelevant choice, to give people the option to build a plant using low-cost, abundant fossil fuels, and do so in a way that limits or eliminates carbon emissions, and not make it an environmental or an economic choice. Make both options palatable in the same facility.
As developing countries try to improve their way of life, how do you see these technologies playing into all of this for those places around the world?
Yeah, I think the developed world sort of built its economies on the back of abundant, low-cost fossil fuel. Those fuels are also abundant in the developing world, and if we want, those folks are going to want to bring the same quality of life and type of lifestyle we have in the developed world to their world, and so fossil fuels are going to be utilized to do that. We have an opportunity to do that differently. We have an opportunity to do that by building from the start even cleaner infrastructure to utilize those low-cost, abundant fossil fuels.
One of the key challenges that have plagued carbon capture projects is scalability. I know your pilot scale project is 1/10 the size of the eventual power plant that Net Power would like to commercialize. What are some of the challenges that Net Power faces in scaling the technology?
Sure. So we started by designing a commercial scale plant rather than focusing on sort of taking R&D and scaling it just to whatever we felt like the next most cost-effective size was. We said, what does the best commercial product look like? And then we scaled that as small as we could to build a demonstration plant without trying to fundamentally alter that design, fundamentally alter the equipment in the plant. So every piece of equipment in that plant is being supplied by a supplier that can also supply the same piece at a larger size. So we're very confident about all the equipment in that facility. The key piece then, the scale, will be the turbine. That turbine doesn't exist yet at a larger scale, but we're benefiting from the fact that that turbine could only be made so small due to the pressures of the system. So it's actually operating at less than its full capacity, and that turbine will actually, in the demonstration plant, it'll actually then scale up to a commercial plant more of a 4x scale up than a 10x. So we really reduced the scaling as much as possible. And eliminated sort of technology changes from small scale to commercial scale.
Interesting. And in your opinion, because we always have this debate on the committee, is what role do you see government playing in helping with the scaling up of the technologies like the one you're testing?
Yeah, as I mentioned in my written testimony at length and in a little bit of my oral testimony, that as you scale up, there are new risks, even if you have the same piece of equipment and you're just making it larger. There's a new turbine in the middle of a plant like this. It's got to operate against very, very mature technologies, such as, say, a natural gas combined cycle plant that's been in the market operating and becoming efficient for 40 years. So it's a very challenging hurdle to overcome. And so when we take that step, you have to figure out how to make that first plant more cost-effective against what's in the market today.
Yeah, interesting. Mr. Chairman, I yield back. Thank you. Thank you, Mr. Dimmig.
I now recognize Mr. Dunn for 5 minutes.
Thank you, Mr. Chairman. It's a fascinating subject. I could quiz you guys all afternoon, but let me jump right in here. Start with Mr. Johnston. The shale revolution, talk about that first. I would like to get a sense of how that actually impacts the average American family, and if you could also tell us, give us a time horizon. How long can we count on our shale revolution to take care of us?
Well, we refer to it as the shale evolution because there was decades of investment and field experiments that went into this, where most people do see it as an overnight occurrence. The average American family today is getting approximately $1,400 back into their pockets through lower utility bills. On the electric and gas side, together, because there's been such a shift in power generation from coal to natural gas and lower gas bills as well. If you look at, just take the Permian Basin, for example, it's just one basin, but it is now like considered by many the world's largest super basin of hydrocarbons, and with estimates of 160 billion barrels of oil, and looking to double and beyond, and you'll see kind of similar growth from natural
What
gas.
technology barriers do you see to continuing to efficiently extract all that potential?
It's really more fundamental learning than I think it is the technology itself. It's really about being able to understand and predict where you actually make the fractures. Because as I pointed out, so many of these are not actually producing toward the overall production of the well. So it's about having a better understanding of how the fractures propagate. There could be some fundamental things in materials in the proppant itself, and having more intelligence with the proppants. But it's really about predictive analytics at this point.
Thank you. So I'm going to turn my attention to Mr. Brower. I loved your bio. Sometime I want to get you come back and tell us how you make a spaceship on the moon, out of the moon. That's a great background there. But I'm going to ask you a different question today. You have a relatively small company, very exciting company. What impact are you going to be making on the shale revolution?
Well, hopefully you're bigger than most of us think. You know, it's the ideas, I think, that are generated that have the impact and not the size of the company. You know, I think back to some of the early pioneers in technology, such as Thomas Edison. You know, just a very small group of people that were able to come up with some great innovations. And you know, he met with a lot of opposition too when he was developing the light bulb. Most people were really opposed to it because they thought, you know, we already have kerosene lamps. Why do we need an electric light bulb? You know, and so I think that we come up with those kind of barriers whenever we innovate something new. There's resistance to anything new in a certain level. Some of it a lot of resistance, and some of it much more gentle. But I think that the concepts are what really make the difference rather than the size of the company.
It's great, and actually I was very fascinated by all the areas you've ranged into professionally in your life. Mr. Dimmig, I'm going to ask you, because you have such a great testimony, more written than oral here, if you can direct us maybe offline to more information on the almond cycle. That's more than we can dive into in the remaining minute we have here. But I'm just going to ask you if you could have somebody send us on the committee more information on how that energy cycle actually works. It's just a simple request.
I'd be happy to do that, thank you.
Thank you very much. And then Dr. Krishnamoorti, so we're talking about an insufficient supply of engineers and scientists. What's the University of Houston doing about that?
Well, we started a petroleum engineering program 7 years ago. We now have 1,000 students in that program. We've created the nation's only subsea engineering program, and today we are graduating about 50 graduate students annually in that program. We've created a program that is focused on upstream data analytics, that is looking at how do you bring all the advances we've done in high-performance computing and data analytics to the upstream world.
So I'm not going to trip you up with that question. That's good job. Thank you very much, Mr. Chairman. I yield back.
Thank you, sir. The chair now recognizes the gentleman from California, Mr. Takano, for 5 minutes.
I thank the chairman. My first question is for Mr. Johnson. Mr. Johnson, data released by the Occupational Safety and Health Administration, OSHA, shows that the rate of severe injuries across various, it shows the rate of severe injuries across various U.S. industries. The upstream oil and gas industry was once again one of the more dangerous places to work, according to this report. It tends to have a low injury rate, but a very high fatality rate. What is the industry doing to improve safety for oil and gas industry workers? Is there anything on the technology and research front that industry is funding or could or could fund to bring the fatality rate down?
Thanks for your question. I grew up as a roughneck on an offshore drilling rig, so this is something kind of personal to me. So, you know, it is a hazardous occupation. I would have to say that safety, it starts with culture and engineering controls, administrative controls, and things of that nature. From the time that I worked offshore in the 80s to what I saw on our hydraulic fracturing test site is a huge transformation in attention to safety and culture and so on. I was very impressed with what our host site Laredo was doing. I'm also our executive sponsor of our corporate EH&S team. So I think it really starts with having that commitment to a safety management system. As far as specific technology, GTI is not developing any technology in the upstream oil and gas sector that's safety related. We do more in the downstream segment of that business with the distribution companies and public safety in that regard. I'm sure, though, that the industry has a keen awareness on that.
I'm not, you know, I'm not from Texas. I'm not
Yeah.
around. I'm just wondering, are the refineries considered upstream or downstream?
Downstream, yeah.
Yeah, I mean, we do have refineries in California.
Yes.
And I know that we've had some serious incidents and accidents in those types of environments. And I'm just wondering if there's any way in which there can be improvement in technology there or more intensive research.
Certainly. There's a great book called Failure to Learn that is a historical recount of the Texas City refinery explosion and the deaths that occurred. Every one of my directors has read it. I bought them all copies of it because I think that's one of the key pieces of that. But there's certainly monitoring technology and advanced controls and things that are continuing to accelerate down the technology path.
Well, thank you. Thank you. Mr. Dimmig, I'm going to try and get this question in. Some of my colleagues across the aisle often complain that the Department of Energy is, quote, picking winners and losers, end quote, and interfering with the free market by, quote, crowding out private investment, end quote. I would be interested in your perspective, given Net Power's experience in utilizing technologies developed by government, as well as in securing private sector investment. Should the department support all research proposals in areas equally, or should it prioritize investments based on where we can get the most value for taxpayer dollars?
I think there should be a priority on value. And I think at the end of the day, if we believe that these technologies, there's a great public interest in having them available to us, and that the R&D was worth it, and we want to sort of get them into the market, ultimately there will be winners and losers selected. And I think the key is to have market pool. The market is very good at picking winners and losers. And so getting the market to really drive those decisions, but have the DOE and the federal government as a partner, I think is a smart way to sort of blend the benefits of both.
Dr. Krishnamoorti, I see you nodding your head. You agree with that?
Absolutely. The idea of having an industry pull is critical in determining what types of solutions we put together. It cannot be done in isolation of industry pull.
Well, has the department picked a lot of important winners in the past few decades, such as hasn't it really picked some important winners and losers in the past few decades, such as breakthrough hydraulic fracturing techniques? And is this a bad thing?
No, I don't think that is a bad thing. And again, there's industry involvement, industry pool that really helped drive that technology into the market. But clearly, the Department of Energy and the federal government had an important role in getting that technology to market and then out the door.
Before I yield back, I'll just note for the record that Dr. Krishnamoorti was also nodding his head.
Did the gentleman yield back? I did, sir. Okay. Did you say that the other side was complaining? You know, we're husbands. It's in our job description. I'm just saying. The gentleman from New York is recognized for 5 minutes.
Thank you, Mr. Chair. The energy challenges facing the United States today are real and growing. The only way to meet these challenges is by investing in research and development. Having an R&D portfolio that covers the spectrum from advances in basic sciences to cutting-edge technology development, testing, and deployment greatly augments the critical work being done by our private sector and at our nation's colleges and universities. Sustained support of these advances produces significant economic dividends for the United States, lowering costs and improving performance of widely used energy technologies. President Trump's fiscal year 2018 budget proposal would deal a critical blow to the United States' cutting-edge innovation and research in the energy field. It would carve away at critical programs, including the Department of Energy's Office of Energy Efficiency and Renewable Energy, DOE's Office of Science, and even the visionary energy advancements being achieved through ARPA-E, the Advanced Research Projects Agency for Energy, with a proven record of moving the horizon of energy research forward. At a time when we should be adding to our investments in our nation's future, these cuts would put American research and innovation far behind that of other nations. Many members claim to support an all-of-the-above strategy for energy production. I believe we also need an all-of-the-above energy research strategy to complement it. I recognize the value of federal fossil fuel research when it helps us to achieve greenhouse gas emission reductions, improve efficiency, and protect Americans' public health and safety. That is why I've authorized bipartisan legislation. I've introduced bipartisan legislation to authorize a gas turbine efficiency R&D program. Without DOE's support, we will lose our nation's advanced manufacturing edge to countries that are investing in advanced turbine research. Instead, with appropriate investments in turbine efficiency research, we can be saving and creating American jobs while we're working to reduce emissions. Simply put, an all-of-the-above approach cannot be limited to oil and gas technology. We must support research targeting renewables, storage, grid modernization, and all other viable options to secure our nation's energy independence and our global leadership in energy innovation. Advanced Research Projects Agency for Energy, or ARPA-E, modeled on the Defense Department's DARPA program, invests in high-potential, high-impact technologies that are too risky for the private sector at this time. ARPA-E is advancing America's competitiveness around the world. It has fostered cooperative projects with academic, federal, and private sector researchers, pushing forward cutting-edge ideas with an eye toward the marketplace. So, Mr. Johnston, as far as it has been widely reported, we understand that ARPA-E is now subject to a no-contract action order, which prevents the program from taking any action to distribute and manage FY 2016 or prior year funds as directed by law. It has also been reported to committee staff that as part of this order, requests for routine no-cost extensions of contracts, which are critical tools for effective program management, are not even being considered by the agency. And GTI is currently leading or participating in several active and announced ARPA-E projects. So to the best of your knowledge, how has this no-contract action impacted the work you do, or what you need to move forward in terms of research?
Thank you for the question. We had received notification of an award through the refuel program back in the fall, and that particular project has not been contracted yet, so it's been delayed. We go through a period of negotiation with contracting officer and the program director, and it's clearly in DOE's court now before that contract is initiated.
Is such an order unusual in your experience?
It's not unusual to have delays when there is an administration change. This one seems to have gone on, a little bit longer than typical.
And in regard to the no contract action?
I'm not sure of the no contract action. I just kind of look at our internal process and see that an award was made, and it's 8 months into the notification. We still don't have a contract.
Mm-hmm. Beyond ARPA-E, have you encountered similar issues in working with or receiving funding from other DOE programs within the last few months?
Have we received others?
Yeah.
Yes.
And such as?
In the Fossil Energy Office, we have a supercritical CO2 Brayton cycle project that's a large project with other partners through the Fossil Energy and NETL.
So what impact will that have?
Of getting that project? Well, we just kicked the project off, and so, you know, our teams are now fully engaged in delivering that project, and it's a team of different research institutes and other researchers.
Thank you. I'll yield back, Mr. Chair.
Thank you, sir. The gentleman from California is recognized.
Well, thank the chair. I thank the witnesses. I'm going to be confining my questions to shale oil. In California, we're very concerned about groundwater. We have a limited amount of it. We have a limited amount of rain. What are the best ways to minimize contamination of groundwater in the shale process, Mr. Johnston?
So as far as groundwater, I think it's all about surface retention. There's, you know, the actual hydraulic fracturing happens so far between, you know, below the groundwater table that there's really, you know, infinitesimally small risk that could ever happen unless you had a surface casing issue. But really, you're probably much more limited to surface type of contamination to groundwater.
From surface
spills or something of that.
Okay. I'm not quite sure I'm convinced, but I've heard that before, so I'll go with that for now. What about, what's the best way to minimize leakage of methane into the atmosphere from the fracking process? Or are you the right person to ask that question?
I'm certainly, I've been around, I was on my first frack job in 1985, so I've been around it for a little bit. Fracturing from the methane emissions from the hydraulic fracturing process are typically lower than they are from actually conventional gas production. As with anything, you know, I think operators want to keep as much of the product as they can. Right. The real significant points of the process that have more or more apt to leak methane would be through the flowback process. And you can have green completions where you actually capture the methane through that process, in the gas processing process as well. So, and sometimes in storage.
So would regulations be the way to encourage companies to use that technology?
What I see that's been very effective to date is when policymakers, environmental NGOs, and industry can come together and have a discussion and develop, you know, policy around that. I look at Colorado, for example. They have what I would consider to be a great case study of how you address methane reductions and a methane target within a state. And then, you know, there's technology. Senator Tanaka, or Congressman Tanaka mentioned ARPA-E. There's a lot of new technology actually coming out of the ARPA-E monitor program that will be there for the commercial sector to bring into account. So a lot more monitoring of more remote sites on the horizon.
Mr. Dimmig, do you agree that environmentalists, industry, and policymakers come together to find solutions?
I do. We work quite extensively with NGOs to try to educate them about what we're doing and learn from them about where their concerns are and figure out how we can address those. Methane emissions is one of those areas. And from our conversations and where we see things with monitoring, many of these emissions issues are very easily addressed. But we have that conversation on the very regularly with NGOs and policymakers.
Okay, good to hear. Mr. Johnston, again, concerning wastewater, there's a significant and growing concern about the wastewater injection back underground causing earthquakes and other sorts of problems. Would it be feasible to require fracking operations to clean up the wastewater so that it can be usable, if not potable?
I think it's, in some instances, is more of a market question because they can dispose of this water so inexpensively, and specifically in what you've seen in Oklahoma and some of the other areas. It's actually not from shale where a lot of this water is being produced. It's from the Mississippi Lime Formation, and that's what a lot of that deep water injection has caused some of the induced seismicity in that Arbuckle formation there. They've seemed to be able to manage that pretty well as they reduce the amount. We're constantly looking for technology and innovations that make that decision very easy for operators to recycle as much of the water and to clean it up and reuse. So that's a big priority for GTI.
Okay. All right, Mr. Chairman, I'll go ahead and yield back. Let you terminate the hearing if you wish.
Actually, I think we're going to do a second round of questions if you have more, Jerry. So hang in there. Gosh, where do I start? Well, let me do it this way. Mr. Johnston, I'll start with you. What policies could Congress and DOE implement to encourage more industry-led development, research and development efforts? Are there existing, in other words, what policies could we implement? More industry-led research. You talked about being a roughneck, basically, back in '85. Is that what you said? Okay. So you've watched this industry develop. So how do we get industry more involved?
Well, one of the reasons I wanted to highlight the project that we have today is just that. I mean, that's tremendous leverage. It's working on a big problem, and it takes lots of different stakeholders to come together and solve the problem. So I think if you set out more grand challenges that can really have an impact for consumers, for industry, for the government to be able to point to the impact that they're making, I think that's the way to do it. It's one thing I really like about, even the ARPA-E model is they put big stakes in the ground and you have to innovate to those. So not be prescriptive, but put big opportunities out there and let innovators in the industry come together to try to solve those.
Okay. Mr. Dimmig, I'm going to come to you offline afterwards. I'm very interested. I own an air conditioning company, and furnaces are about 80% efficient, so natural gas, about 20% of the heat and energy goes out the roof through the vent. And I'm curious about how exactly y'all intend to do something that's zero emissions. But I want to come to the doctor here. When you talk about those kinds of measuring, or maybe it's Mr. Brower, I'm not sure, or both of you, measuring, being able to measure abilities of pipelines, subsea, you talked about ROVs, unmanned ROVs, subseas acting like human capabilities, I think it was you, where you can measure that pressure differential or pressure change. My question is, could that be applied to downhole when that drilling is happening on site? When you've got a wildcat or a rig going, are you able to measure pressure on those kinds of downhole, or is that just out of the question?
Measuring anything downhole while drilling is extremely difficult, right? Ahead of the bit is a real challenge. But there are technology solutions that are coming through right now that are likely to transform that. One is through smart fluids, putting fluids that can actually measure ahead of the bit has become a way to control fluid loss. The other is looking at acoustic signals that are able to look beyond the drill noise and be able to actually tell what's going on in the ahead of the bit. And those are coming along. Perhaps 3 to 5 years, those technologies will be mature.
Okay. Well, maybe if you can shorten that, we can get you more money. I'm just saying. Mr. Brower, would you agree with that?
Yeah, I agree with shortening it too.
And I figured you'd like that.
Yeah, the faster the better. Downhole measurements, like pressure or differential pressure in downhole, is like the holy grail of measurements in that arena. It's very difficult to get. Right after the Macondo incident, I was asked by BP to participate on one of their steering group, and that was one of the items that we addressed. There is ways, and there are ways to do downhole monitoring. As the doctor said, it's extremely difficult. We have certain monitoring methods that we use and are continuing to further develop that are used in the deep water area that we're now starting to put into downhole operations. And so I think in the next in the next few years that it will be very doable to get those differential pressure measurements.
Recently, I'd heard GE's plant where they build blowout preventers that are megatons, and they use redundancy in putting those on the floor of the ocean, for example. So it's a very interesting thing that we can monitor that. But Doctor, I want to come back to you. Mr. McNerney from California had some questions about the water issue. Would you like to further expand on that? You want some more time?
Sure. So there are some very interesting technologies that are in place that are allowing for the use of geothermal energy to clean up the water. These are being done through nanotechnology. There is a startup company from the University of Houston.
Geothermal on-site?
On-site. So they're able to bring, not use fossil energy, but use geothermal energy to clean up water. This is a nanotechnology company called Wave. They've developed these materials that can pull out most of the contaminants that are there and make the water as good as potable water. And that's the kind of thing, even though you can clean it up, the idea is to reuse and recycle that water so that it can be used for refracking or for other fracturing operations. I think that's an opportunity where the challenge has been there. These are technologies that have been developed for other applications, such as in the developing world, where clean potable water has been a challenge. And those are being now brought to bear on the oil and gas industry.
Thank you, Doctor. I'm going to yield my time and go to Mr. Vesey.
Thank you, Mr. Chairman. My question is, again, for Mr. Dimmig. I know that Net Power intends to use the captured carbon dioxide for EOR. If carbon capture technologies are expanded widely across the market with the capacity for additional CO2 EOR meet the influx of carbon dioxide that will be available, or would there be a market saturation?
In most of the analyses we've seen are that there's a huge opportunity for CO2-based enhanced oil recovery, and that opportunity can absorb the carbon emissions from really gigawatts of power plants. So there's a study by Advanced Resources International that argues there are about 100 billion barrels of next-generation CO2 EOR barrels recoverable, economically recoverable, and I think those to recover that oil, it would require 33 billion tons of carbon dioxide. Wow. Which is approximately, I think, it was 260 or 280 gigawatts of natural gas plants over a 35-year life.
Yeah. Wow. So, okay. No, thank you very much. Mr. Johnston, to many, the idea of using carbon captured dioxide to extract additional greenhouse gas emitting resources, in this case oil, seems to run counter to the purpose of capturing carbon dioxide in the first place. Can you explain why CO2 EOR how that benefits the climate?
Well, currently, a lot of the EOR operations come from naturally occurring, so it's mined basically, it's drilled for us, produce the CO2. And if you take anthropogenic CO2 from power plants or other industry and you reuse that in an EOR application, you're actually sinking that. It becomes a miscible fluid. It helps bring up that tertiary produced oil that you can't extract today. So I think IEA did a study where they're looking at if all the potential EOR applications that are technically recovery were done, there would be like a 63% carbon reduction from using man-made CO2 for enhanced oil recovery.
Wow, amazing. So in that same context, can you explain what a carbon advantage barrel of oil actually means?
I would have to infer that it's something on that, guideline. I'm not really dialed into that, but I think it has to do with using the man-made CO2 to bring that oil to bear to the market.
Okay. Do you have an estimate of how much private industry invests in R&D into new technologies annually compared with the Department of Energy's Office of Fossil Energy?
Good question.
Are you talking about across the value
Yes.
chain of oil and gas?
Mm-hmm.
I mean, it's orders of magnitude more than what DOE would put in. Because the fossil energy office is with roughly $600 million a year. I think it'd be orders of magnitude more by industry, you know, across, or you just talking about the U.S. even, it's at least an order of magnitude, probably higher.
Okay, well, that would be interesting to see those numbers. Absolutely. Would the government best fulfill its obligations to the public by pursuing more efficient extraction methods and technologies, or by pursuing more effective environmental protections?
Could you repeat that? I'm sorry.
Yeah, absolutely. Would the government best fulfill its obligations to the public by pursuing more efficient extraction methods and technologies, or by pursuing a more effective environmental protection policy?
Yeah, you know, those things are so closely coupled, and I don't think people realize that, or a lot of people. So, and as I pointed out in my testimony, the more you're driving that efficiency, the more you're reducing the environmental impacts and the community impacts on top of that, which is very important to people. So I think they're much more tightly linked, and it's not an either or. And I think that's the conversation we should be having more.
Mr. Dimmig, did you look like did you want to comment on that? Okay, all right. Well, no, thank you, Mr. Chairman. I yield back my time. Thank you.
He wasn't going to touch that with a 10-foot drill stem. Mr. McNerney?
Well, thank the chairman again. You know, shale revolution really has changed our country's energy outlook. In 2007, we were talking about running out of oil and prices and all, and now we have oil. We're talking about exporting natural gas, but shale has a bad rap. I mean, it does. If you look at the state of Maryland, didn't they just pass a law that would forbid fracking? I mean, states, even Oklahoma, there's a lot of concern out there about shale. So what can we do? Is it more government regulation? Is it just improving technology? I mean, I'm a little bit of a loss here. How do we change that image of fracking as a nasty, polluting, earthquake-causing business? Sure, Professor.
So I direct you to my testimony. There is a report that the Academy of Medicine, Engineering, Science, and Technology in the state of Texas is creating. It's led by one of our UH faculty members, Christine Economides. She's a National Academy of Engineers member. They have looked at all of the different aspects of shale gas, and this is the technology, the water, the infrastructure, and there are best practices in place that can be put in play that will ensure that this can be done safely, can be done economically, and can be done in a way that actually minimizes environmental and infrastructure damage. And I think those are the best practices that have been established in about 10, 12 years of the industry working really hard to do it right. And I think even though there has been a lot of publicity about the ills of shale gas and the unconventional resources, I think this is a resource that, if managed right and if done right, can be an incredible resource for all of us.
Well, I mean, you talk about best practices, okay, but it just takes one or two bad players to give the whole industry a bad rap. And I mean, is it going to take additional government regulation or enforcement? I mean, how are we going to make sure that the industry follows those best practices?
So the challenge is how distributed this resource is and how many operations that are continuously being developed, both drilled and production. And so to try and do this by just simply regulatory oversight is a mistake. This has to be a partnership with the industry and with best practices being put in place and where the effectiveness is monitored by the industry. It cannot be monitored by regulatory agencies.
I don't quite buy that. I mean, that's like saying you're going to have the financial industry regulate itself. No, that doesn't work. Mr. Johnston, did you want to chime in here?
I do think that having unpolarized conversations would be a good start. And I don't know who is the facilitator.
Yeah, we'll get right on that here in Congress.
Yeah, exactly. I wasn't going to bring that up. But anyway, but I mean, that would be a huge start, just to bring the NGOs, the industry, and policymakers together to really lay this up, because we have an unprecedented opportunity. You know, you talk about in our country going to being an exporter of hydrocarbons, and you know, 10 years ago we were talking about building LNG import terminals, and you know.
Now we want to know how to make them export terminals. But
Yeah.
I mean, the thing is, even if the United States, all the players in the United States are good, you know, angels, and they don't ever they follow best practices, then there's other countries in other parts of the world that are going to take up this technology and are going to be bad players. So, I mean, we still have a huge challenge in terms of our leadership and in terms of our example on how we do this.
Yeah, fracking is not a good, you know, name, right? Anywhere you look, and it's painted with a broad brush, whether it's actually the culprit or not. And I don't know how you redirect that conversation, but you know, it's been around since 1947. It's not. And you know, I don't know how you change the conversation, but that's really what needs to happen.
I mean, as a tree hugger, I want to see more renewables and maybe more nuclear, but we can't just turn off. And so we're going to have to rely on fracking, and we want it to be as clean, as safe as possible.
Well, there's ways to do, you know, there are best practices, and I think there are commonsensical ways to address the issues that are out there. Like I said, I pointed to Colorado in the case of methane emissions. That's a great case study. And then how do you take that from there?
All right, thank you, Mr. Chairman. I'm going to yield back to you.
Okay. Well, now that we have fixed all those problems, I want to thank the witnesses for their valuable testimony and the members for their questions. Jerry, thank you for your difficult questions, too. I mean, that's a lot of frank discussion. I appreciate that. The record will remain open for 2 weeks for additional comments and written questions from the members. This hearing is adjourned.